I'm going to give a very quick run through some of the experimental sites that we're looking at. First of all, I'd just briefly like to reiterate that what we are looking at are not biomass plantations or purpose-grown wood. These certainly have their value, and there's enough research going on elsewhere, but our research is on integrating biomass harvests with more traditional forestry operations. So one-time entry, and we're not looking at very quick rotations as they do in these plantations where it can be up to every 15 to 20 years a harvest. Excuse me. To summarize, as Trevor has mentioned, a lot of the area within the Great Lakes St. Lawrence, the forests aren't in the ideal shape the way we'd like them. There are a lot of mixed woods which have been high graded in the past. And so the driving force, or what the question we're trying to see is, can we indeed, with this new bioeconomy, with this new market, can we utilize that market to pay for the silvicultural intervention that it would take to take out some of this lower grade, low quality wood, which has little commercial value right now, and do some better silviculture and restore some of these sites. So turn some of these sites into something in the very long term, mind you, looking more like this. And therefore make the land base productive not only to the emerging bioeconomy, but also to traditional forestry operations. Really very much working in tandem so that we don't get carried away by this bioeconomy and forget to focus on growing high quality species for the traditional forest industry. The biofiber harvests in the Great Lakes St. Lawrence, the more recent, and one of the newest ones was done, the newest of the last few years, was done in 2008, and it was a combination between the Eastern Ontario Model Forest and FP Innovation Ferric, together with the Masno Lanark SFL, and they looked at a variety of forest systems, and the objectives were to look at the technical feasibility of recovering the forest bioproducts, the economics, to determine the silviculture and regeneration implications, but also to characterize the biomass that we pull off these sites for the potential end uses. And this last work is being done at U of T right now. This is just a picture of these sites. At the top there, you can see the pine site where the slash has been taken off and the top's removed and it has been planted. So we're putting long-term sampling plots into these sites to follow the regeneration and any potential site implications some of these treatments might have. There's also control areas. And on the right is just the slash pile where we are now trying to characterize the biomass characteristics. So this site is the most advanced. There's a couple of other sites. Trevor and his company are very busy in the Halliburton forest. We've heard about the Nipissing site, Block 196, the tour tomorrow. In the Algoma forest, together with the Clerg and St. Mary's Pulp and Paper, we're trying to get some biomass trials off there to look at the feasibility. And also, finally, in the Petawawa Research Forest, we're looking at a large pine mixed-wood site where we're looking at how to improve these stands by taking off the lower quality stuff, superimposing some site prep and planting. Now, we're all talking about how innovative this is and how new. I'm not here to burst anybody's bubble, but this bandwagon has been here before, biomass for bioenergy in the late 1970s, early 1980s, when the last oil crisis hit. There was considerable government funding to look at these issues, and there were sites put in place, along with a lot of work on the fast-growing species. As the oil prices dropped, the funding dried up, and a lot of these sites were forgotten about. Well, there's been renewed interest, and we're trying to dig up some of these old sites and see what they tell us about what we did 30 years ago. The oldest site in Canada, the biomass harvesting trial, is at the Petawawa Research Forest, one of our two national forests. It is in a pine, white pine, red pine, aspen forest. This is the uncut portion. This is the control, a picture of the control at present, with Darwin Burgess, one of the scientists who put this in place 30 years ago, standing there. And I'd like you to compare this. This is a whole tree harvest 30 years ago. This place, everything Up to 1.3 meters was cut and taken off the site. The site was not site prepared or planted. Essentially, it was cut and we walked away from it. And this is 30 years later. It has regenerated mainly to aspen and red maple. There is some self-thinning going on, but the aspen and red maple dominate the stand. Now compare this is the whole tree harvest, with the conventional harvest. Here we left everything, everything over 9 centimeters was taken off, and they left some large trees as well as the slash was left on site. Visually, right now, here you can't see many differences. In fact, you'd be hard pressed to tell which site is which. We are putting in some plots to look at the, see if we can pick up differences at the soil level. But that's not the point I'm trying to make. The real point is compare this conventional and the whole tree to the following slide, which was a whole tree harvest, but they went in, they site prepared and planted it to red pine. So they actually took some time and money and ameliorated the site, so it's now a productive red pine plantation. And I show these slides to show, to illustrate that really it's a choice. We don't want to make the same mistake we've done in the past by a quick fix to the current economic situation. Looking into the long term, it's well worth our while to take some of the money, hopefully that we get through new markets, and invest in the silviculture of these sites. And then I think if we all do that and work together and get the policy in place, we will have a viable long-term future for our forest industry and the people of Ontario. Finally, just quickly, the acknowledgements. Sorry, I can't go into any details. Thank you.